Hello there, and welcome to Dreamy Science. I'm so glad you're here. Maybe today felt like a blur, or maybe your thoughts are still orbiting around something unseen. Either way, I'm glad you found your way to this quiet place. Tonight, we won't be rushing through facts or trying to explain it all. Instead, we'll fall inward into the soft gravity of black holes, into regions where time slows, where light lingers, and where silence deepens into something almost sacred. We'll drift through event horizons, into the invisible arms of spinning singularities, and gently brush the edge of theories that stretch reality. You'll hear of stars that vanish without a sound, particles that flicker and fall, and a strange cosmic stillness that holds it all in place. And as we drift, there's nothing you need to understand, nothing to grasp. Just breathe, just rest. Let the wonder carry you like starlight curving around a shadow. If these calm explorations help you unwind, if they soften your thoughts or lull you towards sleep, consider liking and subscribing to the channel. It helps more quiet minds find their way here, one sleepy soul at a time. So now, let's begin our journey, not to escape the dark, but to understand how quiet, how beautiful, and how mysterious it can be to fall inward. Black holes do not devour all light without a trace. They shimmer faintly at the edge, releasing a quiet breath of radiation into the void. This faint glow is called Hawking radiation, a delicate phenomenon predicted by Stephen Hawking, who imagined that, even in the deepest darkness, something might softly escape. It isn't light bursting from the core or firestorm flares from collapse. It's quieter than that. It comes from the edge, the boundary between falling in and falling away. Near the event horizon, space trembles. Virtual particles flicker into being, twin forms born from the vacuum. Normally, these twins would vanish together, canceling each other out in silence. But at the edge of a black hole, one falls in and the other escapes. That single survivor becomes real, a photon drifting outward into space, leaving behind a black hole that has lost just a breath of mass. It is slow, so slow that a black hole the size of a star would take longer than the age of the universe to fully fade. But in time, even giants can shrink, not with a crash, but with a whisper. Radiation becomes memory. The black hole glows not with heat, but with a story, that even the most powerful silence in the cosmos still speaks, in its own time, in its own way. At the event horizon, space isn't smooth. It flickers with tiny probabilistic tremors, quantum whispers just above nothing. This surface isn't hard or visible. It has no edge you can touch, no wall you could knock on. Instead, it is a region where reality itself begins to blur. According to quantum mechanics, empty space is never truly empty. It bubbles, it breathes, it stirs with potential tiny pairs of particles flickering in and out of existence. These are not mistakes in the math. They are part of the universe's fabric, happening all the time. But near the event horizon of a black hole, these tremors become amplified. They are stretched and skewed by intense gravity. Some particles are pulled in, others escape. These random flickers, shaped by the curvature of spacetime, contribute to the strange glow we call Hawking radiation. It's a meeting point of quantum theory and general relativity, two great ideas that usually don't agree. Here, at the black hole's edge, they interact not with thunder, but with static, soft, flickering noise at the boundary of knowing. The black hole does not hum. It does not spark, but the space around it quivers, subtly, and constantly, like the shimmer of heat above a road. It's as if the universe itself isn't finished around the edges, as if reality, when stretched far enough, begins to ripple like water, too faint to feel, too quiet to hear, but always there, waiting. Imagine heat escaping something colder than silence. That's what Hawking radiation is, warmth unraveling gently from the edge of darkness. It isn't fire, and it isn't light in the way we're used to seeing it. It's more like a hush, a faint glow produced, not by the black hole itself, but by the dance of particles just outside its grip. As the black hole curves space-time into its deepest well, quantum fields ripple nearby, like silk stretched across a void. In those ripples, particle pairs are born. Most cancel out instantly, vanishing back into nothing. But sometimes one falls in and the other escapes, becoming real, carrying away a fraction of the black hole's energy. It's a process so slow, so subtle, that for most black holes in the universe, it would take longer than the universe has existed for them to fade completely. Yet it means something astonishing. Black holes are not eternal. They radiate, they shrink, not through violence, but through the quiet logic of quantum uncertainty. This flicker is the thread that ties together gravity, thermodynamics, and information, a whisper that the universe is more interconnected than we imagined. And even here, where light cannot climb out, there is still a faint release, not to be seen, but to be believed. Even the deepest gravity releases its grip, slowly, softly, over unimaginable time. A black hole fades not with a bang, but with a sigh. It's a fading so gentle, it's almost poetic, a massive ancient object growing ever lighter through invisible breath. Over time, the escaping Hawking radiation chips away at the black hole's mass. It doesn't happen quickly. For most black holes, this process takes longer than all of recorded history, longer than the lifespan of stars, planets, and galaxies. But in theory, if left untouched, even the largest black holes will shrink. Their horizons will recede, their temperature will rise, and in the final stages, long after the universe has gone dark and cold, they will flare with one last gasp of light, a burst of particles released in a final quiet blaze. This is called black hole evaporation, though the term makes it sound faster than it truly is. It's less like boiling water and more like frost melting in deep shadow, a reminder that even the most permanent seeming structures in the universe are only temporary. In a cosmos governed by entropy, everything changes, even the things we thought would last forever. Black holes are not holes, and they are not eternal. They are slow, whispering clocks, counting down toward a future where silence grows brighter. When something falls into a black hole, does it vanish completely, or is it written softly onto the horizon like a memory folded into light? This question is more than poetic. It's one of the deepest puzzles in modern physics. Because if a black hole erases information, it breaks the rules. Quantum mechanics insists that information, the state of particles, the shape of their dance, can never truly be destroyed. But black holes seem to challenge that. They take in matter, radiation, even light itself, and show nothing in return. A perfect silence, but perhaps that silence isn't empty. Perhaps the information isn't gone, just transformed. Maybe it's stored along the event horizon, scrambled into patterns we can't yet decipher, or maybe it leaks back out, slowly, encoded in the randomness of Hawking radiation, not lost, but hidden, like a book thrown into fire, where the smoke and ash still contain every letter, rearranged In this way, a black hole might not be a tomb, but a vault, a quiet keeper of everything that once fell in, not erased, but encrypted in the geometry of space itself. And as the black hole slowly evaporates, that hidden information may return, like faint echoes from a forgotten story. Black holes challenge the idea that nothing is truly lost. They hold a contradiction, a place that swallows, yet somehow remembers. This is the black hole information paradox, a conflict between two of the universe's most trusted laws. On one side, general relativity paints black holes as final. Once something crosses the horizon, it's gone, forever hidden, its information erased. On the other side, quantum theory insists on preservation. Information may change, may stretch or scatter, but it cannot disappear. These two truths do not agree, and yet both are foundational. This contradiction has haunted physicists for decades. It's as if the universe is whispering two things at once, that the black hole is both an end and a process, both forgetting and recording. Some theories try to reconcile this by proposing that the information is stored on the surface of the event horizon, never truly gone. Others suggest that it escapes in the random flickers of radiation, or that black holes might one day reveal their secrets through subtle gravitational clues. No single answer is settled. But the paradox itself is strangely comforting, because it reminds us that even the deepest mysteries carry their own questions forward, that forgetting may not be an ending, but a deeper way of remembering, just beyond reach. The event horizon isn't a wall, it's a threshold, a place where paths turn inward and memory is stretched thin. Nothing special marks it, no ripple or flash, but it's where escape ends, where even light, the fastest traveler, must surrender. Anything that crosses this boundary is lost to outside eyes, but perhaps not to the universe. The surface of the horizon may store faint impressions of what falls through, like footprints in deep snow that never melt. In some theories, the horizon acts like a hologram, encoding three-dimensional information onto a two-dimensional veil, not in language, but in the curvature of space, in the soft shifting of fields. It's a place where the past isn't erased, just hidden behind the curtain of gravity. A particle's story, a photon's path, a collapsing star, all written in the subtle warps and textures near this edge. Scientists call it the black hole's memory, a boundary that listens even as it swallows. And though we may never retrieve what goes in, the horizon quietly holds the echo, a promise that nothing truly disappears, only deepens into silence. From inside the event horizon, no signal can return, but just outside, in the trembling, curved space near the edge, particles still dance. It's in this strange region, just past the point of no return, that Hawking radiation begins. Here, quantum fields are alive with uncertainty. Particles flicker into being, and for a brief, breathless moment, they hover, one leaning inward, the other outward. Most rejoin and vanish, but sometimes one particle escapes. It slips into the wider universe, carrying with it a whisper of the black hole's mass. It is not the same as something climbing out. No ship could reverse its fall once inside, but in this quantum window near the horizon, information may slowly return. It's a place not of rescue, but of translation, a way for the black hole to speak, not with words, but with light. These escaped particles drift into space, not announcing their origin, but suggesting it. A trail of warmth, a hint of shape, Like smoke rising from a hidden fire, they reveal the presence of something powerful and quiet beneath. So while nothing escapes the heart of the black hole, something does slip from the edge. Not a rescue, but a release. If black holes pull everything in, white holes do the opposite. They are theoretical objects that push everything out, time-reversed mirrors of collapse. A white hole cannot be entered. Instead of swallowing light and matter, it eternally expels it. Where a black hole's surface is a point of no return, a white hole's surface is one of no entry. Nothing falls in, everything flows out. So far, white holes remain purely theoretical. No telescope has spotted one, no signal has confirmed their presence, but in the equations of general relativity, they balance black holes, like a reflection across time. Some physicists suggest they might be part of the life cycle of a black hole, emerging at the end of evaporation in a burst of release. Others wonder if they lie hidden in our past, bursts of energy that seeded the cosmos in its earliest moments. They may never exist in our universe, or they may dwell in unreachable regions beyond our horizon. Still, the idea lingers. For every inward path, an outward one might echo. For every silence, a counter-silence. Pushing, not pulling. Not all darkness collapses. Some perhaps expands. A wormhole is a fold in space, a tunnel that might connect two distant places. It is a gentle bridge between elsewhere and nowhere. Wormholes arise naturally in the math of general relativity, like shadows cast by the possibility of curved dimensions. If space can bend, then maybe it can fold, and if it can fold, then perhaps two far-off points can touch. Not by crossing distance, but by bypassing it. A wormhole might link a black hole with another part of the universe, or with a white hole, or with a mirror image of our world, folded behind some unseen veil. They may be tiny, unstable, or purely imaginary, but the idea is soothing, that somewhere shortcuts exist, that even the vastest distances might contain hidden passages. The mathematics says yes, the physics says maybe. Reality remains silent, but like a dream tucked into a theory, wormholes remind us that the universe might not just be vast, it might be clever too, not chaotic, but woven, not endless, but looped, and somewhere in that quiet geometry, there may be a path that turns inward and comes out somewhere completely new. Picture space not as flat, but as something soft, something that can bend, ripple, and fold, like cloth gathered gently between your fingers. The cosmos may hide shortcuts between distant corners. These folds wouldn't feel like motion. They wouldn't require engines or speed. They would simply allow 2 points to touch, like pages brought together in a closed book. Wormholes are the imagined tunnels through these folds, not because we've seen them, but because the math allows them. Inside one, distance dissolves. You wouldn't feel acceleration or turn corners. Instead, you would pass through stillness, moving without moving. Of course, wormholes may not be stable. Some collapse before anything can pass through. Others would require forms of energy we haven't yet discovered, negative energy, exotic matter. But even the possibility whispers something hopeful. That space is more than emptiness. It has texture. It responds. And within its folds, secrets may rest. These imagined bridges speak to the human desire, not just to explore, but to connect, to reach across the unreachable, and find that perhaps, somewhere in the fabric of reality, a thread was always waiting. These tunnels, if they exist, might connect not just places, but times, or even worlds with different rules, drifting far beyond what we know. Some ideas suggest that wormholes could link not just two stars or galaxies, but two entirely different universes, maybe one with more gravity or different particles, maybe one where time runs sideways or not at all. Stepping through such a passage would be like falling into a poem, where every rule you know unravels into something new. The structure of the wormhole would need to be protected, held open by energies that defy normal physics. But in the quiet of theory, these ideas persist. They are not predictions, but invitations, not maps, but metaphors made from math. In them, the universe becomes less like a machine and more like a dream, folding and connecting itself in places we cannot yet reach. These tunnels are not about speed or conquest. They are about intimacy, about closeness across distance, about the hope that somewhere, somehow, everything touches, even if softly, even if only in theory. Some believe a black hole's singularity could be an entry point, a quiet door to somewhere else or something else. The singularity is where all known physics collapses, a point not of infinite density, but of infinite mystery. And yet, theories suggest it might not be the end. It could be a turning, a place where space folds back on itself or opens into new terrain. Some versions of general relativity allow for bridges between black holes and distant regions of spacetime. These wormholes, if stable, could be cosmic shortcuts, invisible threads across the fabric of the universe, but most are fragile, requiring impossible forms of matter to stay open. Still, the idea that black holes might connect rather than consume reshapes how we see them. Instead of voids, they become potential corridors, dark mouths that speak of elsewhere. Perhaps falling in doesn't mean falling apart. Perhaps it means falling through silence, through geometry, through an invisible symmetry that links what's lost to what might be found. We may never build ships to sail these passages, but the equations whisper. Connection might live where separation once ruled. In some models, each black hole seeds a new universe. Its collapse births something else, beyond our reach, blooming in the dark. This is the vision of cosmological natural selection, a multiverse where black holes are wombs, not tombs. In collapsing, they pinch space-time so tightly that it splits, releasing a new universe with fresh laws of physics. Each black hole could then be the starting point of a cosmos nested within another. Ours, perhaps, born from such a collapse long ago. We don't see these universes. They slip beyond our horizon, sealed off by the very nature of their origin. But the math allows for it. And more than that, the logic. Universes that produce more black holes might reproduce more often. A quiet evolution, not of life, but of reality itself. And the mouths of black holes, silent as they are, may be the gateways through which this cosmic bloom unfolds. It's a theory made of speculation, but also of awe, suggesting that even in collapse, the universe creates. Even in the deepest dark, something new can grow. Not as a metaphor, but as a process older than stars. When black holes spin, they become more than just points. Their shape stretches, warps, a flattened, rotating mystery wrapped in twisted space. These are Kerr black holes, cosmic whirlpools where mass spins at astonishing speeds. Unlike a still black hole, which is spherical, a Kerr black hole flattens at its poles and bulges at its equator. This rotation doesn't just affect its shape, it alters space and time around it. The faster it spins, the more pronounced the warping becomes, like a spoon stirring honey, thick and golden. Close to the black hole, nothing can remain still. Space is dragged in circles, carried by the spin. This creates a region called the ergosphere, not inside the event horizon, but just outside, where even light must swirl. Within this zone, energy might be extracted. In theory, you could ride the rotation and steal a little momentum, though such ideas remain dreams in equations. The Kerr black hole is more than collapse. It's dance, its structure wrapped around motion, a silent spiral that reshapes our sense of gravity. And in its turning, it suggests that even stillness can hold spin, that even in the deepest quiet, something may be moving beneath. Inside a rotating black hole, space itself spirals inward. Time curves like a whirlpool, pulled softly toward a hidden axis. This internal spiral isn't metaphor, it's geometry. In a Kerr black hole, the singularity is not a single point, but a ring, a loop of infinite density encircling a space where time and direction fold inward. Around it, space churns, not violently, but with relentless elegance. This isn't motion in the ordinary sense. It's the very fabric of reality rotating, a quiet storm where time itself becomes circular. If you fell in, you wouldn't simply fall down. You'd spiral gently, endlessly, toward a place that has no center, only inward paths. Some theories suggest that inside, causality breaks down, that future and past blur into a soft knot, that perhaps, just perhaps, another universe lies beyond. We cannot visit and we cannot test, but the mathematics reveals a haunting symmetry, a black hole that doesn't just collapse, but spins its collapse into something more, a soft gyre, a timeless cyclone, a reminder that even at the edge of knowledge, the universe moves with grace, not chaos, not fury, just a whisper of rotation deep in the quiet dark. Close to a spinning black hole, space doesn't sit still. It is dragged along like mist caught in a tide. This effect is called frame dragging, a gentle name for something so strange. In the presence of a rotating mass, especially one as dense as a black hole, space-time is pulled around it, not metaphorically, truly physically bent and carried along by the spin. Objects near the black hole begin to drift in that same direction, not because they move on their own, but because space itself is moving beneath them. Even light must follow this curve. Like leaves on a slowly swirling pond, every path bends toward the axis of rotation. The closer you drift, the stronger the pull. This subtle spiraling becomes more pronounced the nearer you approach the ergosphere, a region just outside the event horizon where no object can resist being carried along. It's as if the universe forgets stillness. In this spiral, time and space link arms, twirling quietly around a silent center. You would not feel wind or sound or motion, only the undeniable soft turn, as if the cosmos itself were exhaling in circles. Frame dragging is not a storm. It is a lullaby, turning endlessly in the hush. The magnetic fields near black holes twist and arc. They shape plasma into glowing ribbons, dancing just outside the void. These ribbons are not random. They trace invisible lines, pathways of magnetism, coiled by the black hole's spin. The charged particles caught in them spiral into motion, glowing as they accelerate, forming loops and spirals, and sometimes jets. This light, this heat, this movement, all of it takes place at the edge, never falling in, only circling. Black holes themselves may be silent, but their magnetic halos shimmer with activity. As matter falls inward, it tangles with these fields. The twisting creates tension. The tension releases energy, and sometimes that energy escapes in narrow beams that stretch across galaxies. It is a strange kind of proximity, to be close enough to be shaped, yet just far enough to be spared, to dance near the precipice without vanishing. Magnetism around a black hole is not a chaos of sparks. It is choreography, a calm storm of light and charge performed in the silence just before the fall. It is the last moment before mystery, and somehow it glows. Some black holes launch jets, streams of light and matter stretched across space, born from the edge of gravity. They blaze into the dark. These are not beams from within the black hole, but from the chaos just outside. As matter spirals inward, superheated, magnetically twisted, it sometimes escapes along the poles. Twin columns of plasma erupt outward, moving at nearly the speed of light. They pierce galaxies, span thousands of light years, and remain intact across unimaginable distances. Though gravity tries to pull everything inward, these jets push outward with staggering force, a paradox birthed at the brink of no return. It's as if the black hole must exhale before swallowing. No one fully understands how they form or why only some black holes produce them, but when they do, it is as though darkness itself has found a way to shine. These are not explosions. They are steady, focused outflows, the calmest violence in the universe. Light without a flicker, motion without chaos. Carved by invisible magnetic threads, they trace the outline of the unseen. In their shape, we glimpse the drama at the edge, where matter meets mystery and still manages to escape. Matter falling toward a black hole doesn't always vanish. Sometimes it swirls, heats, and radiates, glowing bright before it's gone. This is the accretion disk, a luminous whirlpool of gas and dust spiraling just outside the event horizon. As friction builds, atoms collide, releasing heat and light. The closer the matter falls, the hotter it burns. Some disks shine brighter than entire galaxies, yet the glow doesn't last. It is the light of falling things, a final brilliance before surrender. From afar, we see only this ring of fire, not the darkness beneath, but it tells us the story of gravity's grip, of resistance and release. This glow is not a promise of survival. It is the last visible breath before silence. Still it burns with purpose, illuminating the edge, outlining the invisible. It is beauty shaped by gravity and vanishing shaped by light. The black hole does not emit it, but it permits it, a quiet frame around the unknowable. And in that frame, we see not destruction, but transformation, the soft radiance of becoming part of something vast. Far across the universe, some black holes shine brighter than galaxies. These are quasars powered by matter falling inward, glowing like cosmic lighthouses on the edge of silence. A quasar is not the black hole itself, but the radiance it creates. As gas and dust spiral inward, they collide and compress, heating to temperatures that unleash torrents of energy. This light pours outward, unstoppable, even while the matter it comes from is slipping into darkness. Quasars flicker at the center of young galaxies, lighting up the cosmos from billions of light years away. Some pulse with a rhythm, others hum with steady brilliance. All are ancient, their light born when the universe was just beginning to form structure. They are the paradox of presence and absence, of light born from hunger. To look at a quasar is to see a black hole not in hiding, but in performance, a moment where gravity fuels a spectacle and silence gives way to song. These luminous hearts remind us that even the most devouring forces can cast beauty outward, that within collapse there is still creation, bright, defiant, and fleeting as starlight on the edge of forever. When we observe a quasar, we're seeing billions of years into the past. Its light left when the universe was young, crossing time to reach us in the quiet of night. That light has traveled through expanding space, stretched and softened by the motion of the cosmos itself. What began as ultraviolet may arrive as infrared, its color cooled by distance and time. Every photon is a memory, not just of a place, but of an age. These beams whisper of early galaxies, forming in crowded halos of dark matter, of turbulent disks around newborn black holes, glowing in chaos. And still, the light continued, through dust, gas, gravity wells, and cosmic voids. It was never in a rush. It moved at the universe's pace, guided only by the shape of space. And now, when it brushes against our instruments or the lens of a quiet telescope, it finishes a journey billions of years in the making. To observe a quasar is not to see an object. It is to see endurance, a single thread of brightness pulled across eons, a lighthouse that kept shining even when no one was watching. And in that light, we are connected, not to what is, but to what was, to a silence older than memory, still glowing. Even when the cosmos was only a whisper, black holes had already begun to form. Small seeds growing in the darkness, gathering stars and light into their gravity. Not long after the first atoms cooled and clung together, gravity began its quiet sculpting. Dense pockets of matter collapsed inward, and in their fall, some became the universe's first black holes. These weren't monsters yet. They were quiet beginnings, tiny points of unimaginable weight, wrapped in silence. Around them, the first stars began to burn, galaxies began to swirl, and the universe took its first luminous breath. But even then, the black holes waited, anchoring structure, guiding form. Over time, they fed, slowly, gently, drawing in clouds of gas, swallowing nearby stars, growing with the rhythm of the cosmos. Some of these early black holes became the supermassive giants we see today. Their origins are written not in light, but in absence, in the missing mass, at the center of galaxies, in the way stars move in spirals around emptiness. And so, from the beginning, they were there, not destroying, but shaping, not screaming, but holding. Some black holes were born just after the first stars, not from collapse, but perhaps from dense clouds, falling inward before light had fully learned to shine. These are called direct collapse black holes, born not from death, but from condensation. In the early universe, clouds of hydrogen may have gathered so much mass so quickly that they skipped the step of starbirth entirely. Instead of igniting, they folded inward, quiet and complete. This path leaves no explosion, no supernova, just a soft implosion, a hushed beginning. These black holes may have started larger than typical stellar remnants, giving them a head start in their cosmic evolution. They offered gravity a scaffold, an anchor for galaxies to swirl around, and they did so without ever shining themselves. Born of darkness, from a time before galaxies had shape or light had memory, these seeds drifted through the newborn universe like ink in water, subtle but powerful. In a cosmos still learning how to glow, they already knew how to pull, and through that pull, the future began to form. It's still unclear which came first, stars or black holes, but both are written into the fabric of the early universe, turning matter into story. In the hush just after the Big Bang, As hydrogen cooled and shadows began to form, the first structures emerged, but whether they burned or collapsed first, we do not yet know. Some models say stars came first, ending their brief lives in brilliant supernovae that birthed black holes. Others suggest the black holes formed directly from dense clouds, and stars gathered around them later, like light collecting around gravity. It may have happened both ways. In different corners of space, there was no single script, only possibilities unfolding. But whichever path came first, each needed the other. Black holes helped shape galaxies. Stars lit the way. One consumes, one radiates, yet both arise from the same quiet tension, the pull of gravity, the release of energy. In the vast canvas of the early cosmos, stars and black holes were not opposites. They were partners, points of presence and points of absence, weaving the first patterns into space. And even now, their story continues, one flicker, one spiral, one soft collapse at a time. Some theories imagine black holes formed not from stars, but from the Big Bang itself, tiny and ancient, scattered like secrets through space. These are the primordial black holes, hypothetical, elusive, and deeply strange, born not from death, but from the sheer density of early existence. In those first moments, space was thick with potential, trembling with energy. Tiny fluctuations, denser than their surroundings, may have collapsed under their own weight, creating black holes smaller than mountains, or perhaps even smaller than atoms. If they exist, they would be older than stars, older than galaxies, silent fossils of the universe's first breath, too small to shine, too quiet to detect directly. They might drift between stars, hidden in the dark. Some wonder if they could explain dark matter, the unseen mass that tugs at galaxies. Others see them as mathematical relics, beautiful but unproven. Still, the idea holds weight that in the first heartbeat of time, gravity whispered and something listened, that in the lightless beginning, small mysteries were born, and they are still with us, scattered, ancient, watching without eyes. Not all stories begin with light. Some begin with silence. We still don't know what dark matter is, but some wonder if ancient black holes, invisible and silent, might be what we've been searching for all along. Dark matter doesn't shine or reflect. It passes through us, through stars, through galaxies, unnoticed, except for its gravity. We see its fingerprints in how galaxies spin, in the way light bends around clusters, in the structure of the cosmos itself, but the substance remains unnamed. One theory suggests that black holes, not the giants at galactic hearts, but smaller, older ones, might account for this missing mass. Not primordial dots of gravity, too small to notice individually, but too numerous to ignore. If they drift through the galaxy like wind through trees, we would never feel them, but their pull would be everywhere, binding galaxies, guiding motion, a cosmic ghost net, spun in silence. We search for them in flickers of light, in tiny gravitational lensing events, in the motion of stars. But maybe they're just too quiet, too ancient, too perfect at hiding. Still, the idea lingers that the universe's missing matter is not matter at all, but history, compacted, hidden, waiting. What if black holes could be smaller than grains of dust? Not just cosmic giants, but tiny knots in the weave of space, flickering in and out of existence. In theory, if enough mass were packed into a minuscule space, a black hole could form, even at atomic scales. These aren't the giants at the hearts of galaxies, but ephemeral specks, born from quantum tension. Some physicists imagine them as momentary, appearing from vacuum energy, then evaporating in a breath of Hawking radiation. They might flash into being within high-energy collisions or moments after the Big Bang. If they ever existed, they could have evaporated long ago, leaving only a trace of influence. Or perhaps they still flicker, too fast and too faint to catch. It's a thought experiment, yes, but it opens a window into the strange interplay between quantum mechanics and gravity, where certainty softens and reality hums with possibility. These microscopic black holes might be the smallest mirrors of the cosmos, paradoxes of presence and absence, compressed into the silence between particles. And in imagining them, we step closer to understanding what space itself is made of. Not just stars and dust, but mystery woven tight. As tiny black holes fade, they release bursts of energy, like whispers from the quantum world. They leave behind no mass, only memory. This fading is not sudden. It's a quiet unraveling. Known as Hawking radiation, the process suggests that black holes lose mass by emitting faint particles, born from quantum fluctuations near the event horizon. Over time, they shrink, their gravity softening, their darkness thinning, until, in the end, they vanish, not with an explosion, but with a whisper. The energy they release may ripple outward, a final breath in the fabric of space-time. No debris, no light, just the fading echo of something that once bent reality. These echoes may linger as gentle imprints, like footprints in soft cosmic dust, invisible but real. In this theory, even the most absolute silence eventually gives way to release. Black holes are not eternal prisons, but temporary sculptures of gravity and time. And as they evaporate, they return their borrowed energy to the universe. Soft gifts from the edge of existence. Nothing is truly lost, only transformed, dissolved back into the hush from which it came. At the smallest scales, space might not be smooth. It might bubble, shimmer, and tremble. A frothy quantum foam with black holes no larger than a breath. This idea arises from the quest to unify quantum mechanics and general relativity, two languages of reality that don't yet speak the same. In this imagined realm, space-time itself becomes granular, not continuous, but stitched from tiny fluctuations, popping, vanishing, reforming. Picture the surface of a quiet pond, seen impossibly close, where each ripple becomes a world. In this froth, minuscule black holes might blink in and out of being, momentary folds in the weave of existence. They are too brief to measure, too soft to hold, yet they may shape the very texture of the cosmos. Here, gravity becomes probabilistic, and space becomes alive with possibility. The smooth curves of Einstein's universe are replaced with a trembling quilt of maybes. It is a place not of things, but of tendencies, of patterns waiting to form. And perhaps, beneath everything we see, this foam still bubbles, carrying the rhythm of creation in its ever-changing fizz, a breath, a blink, a beginning. An event horizon isn't a surface you could touch. It's a gentle divide, where time flows one way and escape becomes impossible. There is no wall, no edge you'd feel beneath your hand, just a boundary written in gravity's language, a horizon that changes what's possible. Outside it, light can still leave. Inside, even light is caught. But this threshold isn't harsh, it's smooth, a transition like the hush between waking and dreaming. If you were to cross it, nothing unusual would greet you. No alarm, no signal, only the quiet knowledge that your path now bends inward forever. To distant eyes, you'd appear to slow, to stretch, to fade, never quite crossing, never quite gone. This is the strange mercy of relativity. Time flows differently near great gravity, and so the event horizon is not a prison gate, but a shifting veil, a soft silence where direction becomes destiny, a place where physics takes a breath and lets go. You would not feel the moment you passed it, but the universe would know, quietly, gently, completely. At the horizon, light stretches and slows. To a distant observer, it never quite disappears. It just lingers, frozen on the edge. It's as if the light is caught in a spell, paused in place, its energy stretched thinner and thinner as it climbs away from the black hole's pull. This effect is called gravitational redshift, where light loses color and strength the closer it is to gravity's heart. Near the event horizon, this redshift becomes so extreme that the light appears frozen, still, hovering like a memory pinned to the fabric of spacetime. From far away, we never see it fall. We see only the shimmer, the last flicker, suspended forever on the edge. It's a trick of time and distance. To the falling photon, the journey continues, but to the watching cosmos, it is eternal, a ghost of motion, a whisper of what once was. This slow fade is not a loss, but a lingering, a final glow at the border between freedom and silence. The horizon becomes not a threshold of absence, but a mirror of delay, a place where light forgets to leave. From far away, a falling object never crosses the horizon. It slows, dims, and fades, suspended like a ghost on the skin of space. To someone watching from a safe distance, the falling traveler appears to stall just above the event horizon. Each second, their movements slow. Each heartbeat, their light grows dimmer, stretched by gravity's grasp. Time for them continues, but for the distant observer, it dilates, stretches, becomes infinite. The falling object is not seen to vanish, only to fade into stillness, like mist dissolving into dusk. It becomes part of the horizon itself, a soft shadow etched into the silence. This is relativity's illusion. From one perspective, the journey ends. From another, it has only just begun. And so, black holes hide their secrets not just in darkness, but in perception. They bend time into riddles and make observers part of the story. From afar, the edge of a black hole becomes a mirror, not reflecting light, but the strange stillness of time suspended. But for the falling traveler, the journey continues. Time feels smooth, and the horizon passes without pain, like slipping beneath a surface with no ripple. There's no jolt, no flicker, just the soft continuation of motion drawn inward by gravity's lullaby. As they pass the horizon, nothing announces the transition. No surface is touched, no threshold is marked. The traveler drifts inward, and the universe curves around them like velvet. Space narrows, time elongates. Ahead lies the singularity, a place where the known laws of physics unravel into silence. But on the way there, everything feels normal, though subtly different. Directions change their meaning. Light bends in unfamiliar ways, but it is not violent. It is slow, inevitable, tender. Like drifting beneath deep water, the pull grows stronger. The outside universe fades into abstraction, a memory dimmed by distance. And so the traveler continues, not falling down, but deeper into gravity's dream, deeper into the quiet fold where light cannot follow, and time has no escape. The closer you drift toward the horizon, the slower time flows, not just for you, but for your very heartbeat, your thoughts, your light. To an outside observer, It seems as though you are being gently paused, stretched across moments that never quite pass, but for you, everything feels steady. This is gravitational time dilation. As gravity deepens, time thins, your pulse softens, your thoughts ripple slowly like waves beneath ice. The universe outside you appears to speed up. Stars seem to race, galaxies blur past, but within your own experience, time cradles you. It doesn't rush, it deepens. Clocks near the horizon do not tick like those in open space. They soften, drawn into the rhythm of gravity's breath. You become part of that breath, slowing, listening. This isn't a halt, but a hush. The edge of a black hole is not violent. It is contemplative, a place where time folds itself more tightly, and your existence becomes quieter, more stretched. And just before the moment of crossing, everything around you grows distant, almost timeless, a prelude to stillness. Even atomic clocks tick slower near a black hole. Time becomes soft, stretched like silk pulled across space. Precision fades here. The most accurate instruments we've built, delicate clocks that measure nanoseconds, grow sluggish in gravity's arms. A second near the event horizon is not the same as a second far away. It is longer, slower, widened, a breath drawn out over eternity. And though the clock may still tick, its rhythm is no longer universal. Near the black hole's edge, time becomes local, personal, a whisper meant only for the one who listens. Even light, which travels at a constant speed, carries this delay, stretched into red, softened into memory. The deeper you drift into gravity's fold, the more the universe outside rushes past. This distortion of time is not a glitch. It is a feature of spacetime itself, a soft curvature where gravity and time merge into something woven, something fluid, something slow. In this space, clocks do not count down. They sigh. Near a black hole, gravity isn't just force, it's tempo. It bends time, curves moments, and sculpts what a second means. It's no longer just the pull of mass on matter. It becomes rhythm, the pacing of existence itself. Here, near the horizon, gravity reshapes the meaning of now. Seconds stretch into lullabies. Minutes melt into soft eternity. You're no longer moving through time. Time is moving around you. This deep gravitational field doesn't just attract, it sculpts space-time, curling it into slow spirals where clocks tick in unfamiliar patterns. To someone far away, you are slowing, lagging, almost paused, but within, your own sense of presence remains undisturbed. That's the mystery. Time is relative, molded by where you stand, by how deeply gravity holds you. The nearer you are to the singularity, the more pronounced the warping becomes. You fall inward, yes, but more truthfully, you fall across time's surface, pulled toward a moment that stretches forever. And in that stretch, gravity becomes not just a shape, but a tempo, a quiet conductor, drawing out each note of your being. As you approach the core, the gravity begins to pull more on your feet than your head. Space stretches you gently, then completely. This difference in pull is known as a tidal force, and near a black hole, it becomes profound. Your body begins to lengthen, softly at first, as if being drawn into a dream. The force is not harsh in the beginning. It's slow, like thread unspooling, but as you descend further, the difference grows until even atoms feel it. You are stretched, not just physically, but temporally. Time at your feet and time at your head no longer agree. You are moving through a space where direction loses meaning. where up and down dissolve, and only inward remains. And in this stretching, a silence grows, not the silence of sound, but of separation, as each part of you is pulled at a different rate, like ripples in liquid time. This is spaghettification, the poetic term for a process that sounds almost tender, but carries the weight of finality. Yet, in this sleep narration, we imagine it not as horror, but as transformation, a quiet unwinding into gravity's embrace, a becoming of something else, drawn out not in pain, but in soft surrender. It's a strange word for a quiet fate, pulled long and thin by gravity's difference, a slow unraveling, drawn toward the center. The name may sound whimsical, but its rhythm is gentle. It describes the way gravity increases over distance, how a black hole's pull is stronger at your feet than your head, stronger still at every atom along your body. And so you stretch, like thread through a loom, not ripped, not torn, just slowly elongated, as if gravity is painting you into the very lines of space-time. This stretching isn't sharp, it is gradual, a deep, patient force sculpting your form into gravity's art. From afar, the process seems frozen in time. Up close, it's a passage, slow and smooth, without a moment of rupture, a transformation more than a destruction. The boundary between body and time begins to dissolve, and what was once a single shape becomes a line, an echo slipping inward, softer and longer with every breath. Spaghettification, though comically named, becomes a lullaby, a way to whisper into the center of gravity. Beyond the horizon, all paths lead inward. There are no detours, only one direction, toward the silent singularity where space itself ends. Here, inside the horizon, every possible motion curves inward. No matter how you turn, you are carried closer to the core, as if falling not through space, but through inevitability. There is no north, no escape, only a direction called deeper. Time folds in on itself, space narrows, light itself cannot turn away, and at the center, the singularity, the known laws of physics give way to mystery, a point of infinite density where the curvature of space becomes so sharp it breaks our understanding. But this breaking is not violent here. It is whispered, a hush, a final breath as the fabric of space-time bows inward toward something unknowable. You are not destroyed. You are transformed into a question, one that the universe holds in silence. And in this drift, in this soft descent, the journey ends, not in noise, but in quiet surrender to the center that waits without waiting. At the center of a black hole, equations stop making sense. Gravity curves so tightly, space and time collapse into a single, unknowable point. We call it a singularity, but that word is just a placeholder, a symbol for where our understanding fades into shadow. It is not a place you could visit or a thing you could touch. It is the end of space-time, folded inward so steeply that no map can follow. At this center, gravity is infinite, density unfathomable, and time itself ceases to behave. The very tools we use to describe the cosmos, calculus, relativity, quantum fields, lose their meaning. They melt in the presence of the singularity's silence. It is a region where here and now no longer apply. But that does not mean chaos. It means mystery. It means that even in our deepest science, there are places that remain sacred, quiet, and undefined. The singularity is not destruction. It is the edge of knowing, a gravitational breath held forever. We call it a singularity, but we don't know what's really there. It may not be a point, but a mystery, waiting beyond what math can reach. Perhaps the singularity is not a place at all. Perhaps it's a veil, a boundary between what we understand and what lies beyond. Some theories suggest it may be smoothed by quantum gravity, that the infinite collapse might be softened into something else entirely, a loop, a knot, a hidden landscape beyond our dimensions. But for now, it remains an abstraction, a symbol for a silence too deep to chart. It humbles even the most advanced equations, defies the finest models. And that is its beauty, that in all our precision, we still find places where we must whisper, not declare, where we must imagine, not conclude. The center of a black hole may never reveal itself, or it may unfold in time, but for now, it remains a quiet unknown, patiently waiting at the end of gravity's path. To describe what happens inside, we need a new kind of physics, one that blends gravity and quantum rules like threads in a deeper fabric. Einstein's relativity paints the cosmos in wide strokes, curves, waves, the geometry of spacetime itself. Quantum physics, in contrast, works in flickers and probabilities, in trembling particles that vanish and reappear. But black holes ask for both. They demand a language that can speak to infinite gravity and microscopic uncertainty at once, a fusion of the vast and the tiny, the continuous and the discrete. This language doesn't yet exist, not fully, but scientists dream of it. Some call it quantum gravity. Others imagine a deeper thread beneath reality's surface. It would be a physics of softness, of folding, of resolution, not to solve, but to reconcile. Inside a black hole, we believe this new theory would tell us what truly happens at the singularity. But until then, we drift in graceful uncertainty, not lost, but listening. And in this pause, this moment of not knowing, we discover the humility at the heart of science, the acceptance that even silence can be part of the truth. Some theories imagine space made of tiny strings or spinning loops, not points or planes, but trembling patterns beneath what we call real. String theory suggests every particle is not a dot, but a vibration, a note played on a one-dimensional filament. Loop quantum gravity imagines space itself as a mesh, a weave of loops so small they vanish from sight. Both ideas point to something deeper, that space-time is not smooth, but textured, not flat, but rippling with unseen structure. These trembling shapes could be the building blocks of black holes, of galaxies, of dreams. They do not follow classical rules. They flutter and blur, combining certainty with shimmer. At the edge of a black hole, perhaps these threads tighten. Perhaps the loops twist into gravity's whirlpool. Perhaps what we call a singularity is simply where these patterns knot too tightly to untangle. We don't yet know, but in thinking of the universe this way, as a song, a fabric, a tremble, we begin to feel its softness, its mystery, its pulse. Space is not still. It's breathing, humming, and folding, even now. When something falls into a black hole, its information may not vanish. It may be encoded delicately across the horizon's surface, a quiet ripple in time. This idea changes everything. It suggests that the black hole surface, the event horizon, might be more than just a boundary. It might be a memory, a shell that holds the shape of everything that's ever fallen in, not in objects, but in impressions, not in form, but in pattern. This is the holographic principle, that the three-dimensional world inside could be described by a two-dimensional surface outside. It's as if the black hole whispers every secret it swallows onto its skin, a shimmer, a flicker, a silent record barely there, but real. This means that nothing is truly lost, only transformed, hidden in the folds of space and time. Even in the deepest gravity, there may be preservation. The universe, it seems, is more patient than we imagined, and in this patience, we find something comforting, that even the things we cannot see or hold might still be remembered. Some theories suggest a ring of fire burns at the edge, a paradox wrapped in flame, not heat, but quantum contradiction. This is the firewall paradox, a riddle that challenges both physics and intuition. According to relativity, crossing the event horizon should be smooth, a silent drift into darkness, but quantum mechanics, protecting the laws of information, seems to disagree. It predicts a searing wall of energy at the horizon, a firewall where falling matter is incinerated. Two truths, one soft, one blazing, and yet both are grounded in our best understanding. The contradiction hasn't been resolved. It remains like a candle flickering in the equations. Some physicists believe the firewall isn't real, that it's a clue pointing to deeper harmony. Others suspect we've misunderstood the edge of space itself. But in this mystery, we find beauty, that the universe is still asking us to listen, to imagine gently, to wait, because whether the horizon is smooth or burning, it still holds silence, and even flame in the vastness of space can be quiet. What if the three-dimensional world we know is a projection, a shadow cast from a flat horizon, like a memory stored on the surface of space? This is more than science fiction. It's a serious theory born from black hole physics. The idea that everything inside a volume of space can be described by data on its surface, as if the universe were a kind of cosmic hologram. In this view, the world we touch and breathe in might be written somewhere else, not diminished, but echoed. A three-dimensional experience woven from two-dimensional information, like depth emerging from shimmer. Around black holes, this principle becomes vivid. The horizon may hold all the data of what falls in, preserving the shape of space within, like a memory etched in silence. It's a comforting thought that nothing is truly lost, only transformed and stored softly, patiently. If this is true for black holes, it might be true for the cosmos. Maybe everything that exists is projected from something even more fundamental, a deeper layer where space and time dissolve into code, rhythm, and meaning. And maybe, just maybe, you too are part of that story. Not separate, not forgotten, but folded into the quiet memory of the universe itself. The holographic principle whispers that the universe might be encoded elsewhere, that what we live inside is a reflection, not illusion, but echo. If the cosmos is a hologram, then we are made of echoes, not empty ones, but filled with resonance. Our lives, our breath, our thoughts might all be imprinted across some distant horizon, dancing as patterns in an invisible field. These echoes aren't false. They're layered, real and remembered, present and projected, like a shadow cast by light we cannot see. In this view, the universe holds us gently, not as fleeting sparks, but as lasting impressions in the weave of space. Black holes, with their encoded skin, offer a model. They remind us that even in silence, meaning can endure. Perhaps what we call here is always both surface and depth, both now and everywhere. Perhaps memory is the truest form of being, and in this soft unraveling, we find peace, that we are not isolated stars in the void, but luminous reflections flickering quietly on the surface of something vast and kind. and deep. In this view, gravity itself emerges from information. Reality is not built from matter, but meaning. The things we see and touch, stars, planets, even your hand resting softly now, might not be the deepest layer of reality. Beneath all matter could lie something quieter, information, not as code or symbols, but as fundamental patterns, like the hum behind a melody. Black holes have taught us to think this way. Their boundaries encode the stories of what has fallen in, not as weight or shape, but as bits of data, shimmering faintly at the edge. And if black holes behave this way, perhaps the whole universe does. Perhaps space-time is stitched together not by atoms, but by knowledge, by relationships, by memory. Gravity then becomes a response to information, not a force, but an emergent effect, like the way warmth arises from many small motions, or how tides follow the moon's silent pull. It changes how we think of existence. We are not just things in space. We are meanings arranged in harmony. We are remembered, recorded, and reflected, even when we feel most alone. Perhaps gravity is not a force, but a tendency, a soft folding of information, curving the space around what exists. It's not a push or a pull, not a shove from above. Gravity, in this view, is more like a sigh, a settling. Wherever information clusters, where patterns grow complex, space curves, it bows in response, folding gently around the presence of being. This is what black holes teach us, that where the most information gathers, the deepest curves appear, not by magic, but by inevitability. Like water around a stone, space conforms to meaning. If true, this changes everything. It tells us that existence is not built from bricks, but from balance, from relationships and remembering. You are not held down by some invisible hand, but by the story your presence tells the universe. You weigh not because you're heavy, but because you matter. Gravity listens, and in the hush of that listening, the world bends to meet you softly, without noise, without effort, just the quiet hum of being shaping everything around it. Every object with mass creates a dimple in space-time. Black holes are the deepest of these. Not holes, but wells with no bottom. Picture a soft sheet stretched wide. Place a pebble on it. The sheet curves gently. That curve is gravity. Now imagine a planet, a star, a galaxy, each one a deeper fold. And a black hole, it's not just a curve, it's a plunge, a well so deep the bottom disappears from view. But it doesn't tear the fabric, it shapes it, it holds it, like a pause in motion, a deep breath. Black holes curve space so steeply that nothing can escape, not even light. But they do not rip or destroy, they cradle. Everything near them moves as if following a silent rhythm, drawn toward that dark center, and yet, from the outside, they appear calm, still, as if their immense pull were a kind of stillness, a quiet gravity, holding space like cupped hands. They remind us that presence isn't always loud. Sometimes it's depth, stillness, weight. Stars circle black, holes they cannot see. Pulled by something silent, they move in perfect arcs through emptiness. We've watched them, these stars dancing in the dark, bright specks looping around what appears to be nothing. Their paths tell us everything. They curve sharply, speed up, and swing back again, as if tethered to an invisible point. We call it Sagittarius A, the black hole at the heart of our galaxy. It emits no visible light, but the stars don't need to see it. They feel it. They follow its pull, like moths to a flame they cannot touch. These orbits are maps of gravity, not drawn in ink, but etched in motion. Each curve is a signature, each sweep a trace of the unseen. It's a gentle reminder that not all truths must be visible to be real, that even the invisible can move us quietly, completely. At the center of our Milky Way lies Sagittarius A. We cannot see it, but nearby stars trace elegant loops around its gravity. It is a silent presence in a luminous sea. No light escapes its grip, yet its influence stretches across the galaxy. Around this invisible center, stars perform an ancient ballet. Tight orbits carved in patience and precision. They arc and spiral, caught in the soft curve of something they cannot see. Telescopes track their motion, and from the dance alone, we learn. Sagittarius A weighs millions of suns, yet it whispers rather than roars. It draws in time, light, and space with the gentlest of inevitabilities. It does not demand attention. It simply exists, still and constant, a calm pivot in the swirl of cosmic breath, and in its steadiness, it holds the galaxy together. Every star, every planet, every drifting cloud of gas owes its place in the spiral to this unlit axis. Like the hush at the center of a turning wheel, it moves without moving. And as we peer into the dark, we are reminded that not all mysteries shine. Some rest quietly, anchoring everything. These stars move quickly, tightly, as if caught in a hidden waltz. Their paths reveal what their eyes cannot, a black hole, dark and still. They move with purpose, tracing arcs that seem too perfect to be random. These stars, some flaring, some dim, do not drift. They orbit, and with every pass, they sketch the boundary of something vast and unseen. Their choreography is silent but precise, each orbit like a signature on the skin of space. It is through their motion that Sagittarius A becomes visible, not to the eye, but to understanding. Even in the quiet vacuum, their momentum speaks, a gravity-woven story told in motion alone. As we observe them, year after year, their rhythm becomes familiar. We watch them accelerate near the center, then drift outward, only to return again. Like dancers pulled toward a silent partner, they move through centuries of night, and in doing so, they reveal a truth, that the most powerful presence in the galaxy may be the one we cannot see. The stars show us that darkness, too, can be a guide, that absence can shape motion, that mystery, gently held, becomes understanding. It sleeps mostly, but sometimes it stirs, releasing flares, light, and questions into the surrounding sky. Sagittarius AY is not entirely silent. From time to time, it blinks, not with eyes, but with bursts of energy. X-rays, radio waves, and flickers of light ripple outward from the darkness, brief and mysterious. These flares are not violent. They are quiet pulses, soft awakenings, reminders that the heart of our galaxy is not dead, only resting. Scientists believe they're caused by matter drifting too close, heated, twisted, then flung outward in luminous arcs. These outbursts last just minutes or hours, then fade again into silence. To us, they are like distant thunder, low, slow, rolling through space. Each flare carries stories of motion, pressure, and gravity at the brink of collapse. And though the black hole returns to slumber, the memory of its flicker lingers. A celestial exhale in an otherwise breathless night. It reminds us that even the most dormant forces hold the capacity to stir softly in time. Sagittarius H is dormant, but once, long ago, it may have burned like a beacon. The past is written in light, and some of that light still echoes. In the halo around our galactic center, strange structures glow faintly. X-ray chimneys, gamma ray bubbles, radio wisps that rise like old smoke. These may be the remnants of ancient activity, a time when Sagittarius was more than quiet, when it fed and roared and sent waves of energy rippling across thousands of light years. That time has passed, but the memory remains in the sky. Even now, it waits, it rests, but someday it may wake again. The black hole at the heart of our galaxy is not gone. It is breathing in centuries, its pulse slow but sure. And though we live in the hush between its heartbeats, we are still held in its rhythm. When matter falls inward, it heats and glows. Sometimes it escapes just before the edge, sending out brief, bright whispers of energy. In those final moments before surrender, some particles spiral faster, compressing into heat and light. The friction, the tension, the twist of magnetic fields all combine to birth flashes of high-energy radiation. X-rays pulse into the void, a quiet signal from the very brink. These are not storms. They are murmurs, soft flickers that barely ripple the great silence, but speak volumes to those listening. Telescopes capture these whispers and translate them into traces, arcs, and pulses. They tell us where matter paused, where it lingered on the edge of no return. And though the light fades quickly, the memory it leaves is etched in starlight. Each flare is a fleeting hesitation, a moment when gravity almost claimed everything, but let a sliver slip away. These glows are not fireworks. They are sighs from the cosmos, exhaled into the dark, shimmering for a breath, then gone. Black holes feed not with hunger, but with gravity. They gather gas, dust, and starlight into spirals, glowing just before they vanish. Around them, accretion disks form, thin, spinning halos of matter slowly falling inward. The motion compresses everything. Heat builds, light erupts, but it is not chaotic. It is structured, smooth, like a whirlpool made of fire and silk. From afar, these feeding black holes shine brightly, sometimes outshining entire galaxies. Their glow does not come from the hole itself, but from the journey inward, the spiral, the compression, the final dance before the plunge. It's a luminous ritual, performed again and again across the universe. Sometimes the disk flickers, sometimes it steadies, but always it turns, painting circles in the dark. And when the last of the matter crosses the horizon, silence returns. Yet in that silence, the memory of light remains, like a dream of a meal that ended long ago, still warm in the quiet. Around some black holes, matter forms a glowing disk. It swirls in, heating with friction, until it falls too close and disappears. This spinning ring is not chaotic. It's elegant. Like a ribbon of light drawn slowly into a whirlpool, matter orbits in widening spirals that shrink with time. As it turns, the gas and dust collide, compress, and heat. Friction stirs warmth from the coldness of space, and that warmth becomes light. X-rays, ultraviolet, even visible glimmers sometimes. These glowing disks are among the brightest structures in the universe, yet their brilliance is born from silence. No sound travels there, only motion and heat. Each rotation is a countdown, each flicker a farewell. The matter glows brightest just before it crosses the horizon, as if offering a last moment of presence before dissolving into the unknown. The spiral itself is not frantic. It's steady, graceful, like water slipping down a drain in slow motion, drawn by an invisible tide. Around black holes, these disks are the soft outlines of appetite, not hunger as we know it, but gravity's quiet reach, its ability to gather and let go without a sound. These disks create powerful magnetic fields. invisible threads that twist and pull, shaping jets that burst outward from the shadows. Like strings strummed without sound, magnetic lines arc through the space above the accretion disk. As the disk spins, so do these lines, winding tighter, storing tension, ready to release. And when they do, matter is flung outward in narrow beams that stretch for light years. These jets, though born from collapse, shoot away from the black hole, not toward it. They escape, glowing, riding the invisible scaffolding of magnetic force. In this silence, we find a strange balance. Matter falling inward, energy bursting outward, all shaped by lines we cannot see. The magnetic field becomes a sculptor, carving motion from emptiness, forming pillars of light from collapse itself. These fields are not chaotic threads, they are guides, gentle and precise, determining where the light will go, how far it will travel, and how long it will shine. And though we cannot touch them, their fingerprints are everywhere, traced in plasma arcs and the glow of distant jets. In their silence, they shape light itself, a dazzling beam of light and energy aimed like a flashlight through the cosmos. Blazers are among the brightest things in the sky, not because they are loud, but because they are aligned. When a black hole's jet faces Earth directly, the light it sends is compressed by its motion. Time tightens, frequencies rise. The jet, already powerful, becomes a focused stream of radiation and energy. It pulses in waves of light, like a lighthouse whose beam never strays. Yet even this fierce brilliance has a strange serenity. It travels quietly for millions or even billions of years before touching our telescopes. No sound, just a message of motion and alignment. The center of the blazar remains hidden, swallowed by its own brightness, but its jet gives it away. And though the beam may blaze with intensity, it is born from the same soft spiral of the accretion disk, the same magnetic scaffolding, the same slow gravity. It's a paradox of brilliance and silence, speed and stillness. In the grand night of the cosmos, a blazer is a singular flashlight, one that cuts through the dark, not to chase shadows, but to remind us they're there. We cannot see a black hole directly, but with vast networks of telescopes, we can map the glow around it and glimpse its shadow. The event horizon. Telescope wasn't a single eye, but a chorus. Observatories across the planet linked together, synchronized by atomic clocks, gathered whispers of light from a distant black hole. The glow came from matter spinning near the event horizon, bright, hot, bent by gravity into a ring of fire. And in the middle, a shadow, the silhouette of the black hole itself. It wasn't black in the usual sense. It was absence, framed by presence, a dark circle that marked where light could not escape. This was not a photo like we know it. It was data turned into vision, frequencies transformed into shape. And in that shape, we saw proof, gravity bending space, light curving through time, a hole not in matter, but in the fabric of the universe itself. We saw it not with eyes, but with math, memory, and long patience, a shadow drawn in silence. The image of a black hole wasn't taken with one telescope, but many. Earth itself became a lens, listening to radio waves that curved around the dark. To see what can't be seen, we stitched together a planet. Observatories in Antarctica, Spain, Chile, Hawaii, and beyond, all synchronized, all tuned to the same whisper of radio waves from the edge of a galaxy. Each telescope, alone, could only sense a fragment, but together they became one instrument, as wide as Earth itself. The signals were delicate, arriving faintly after 55 million years in flight. But when, woven together with exquisite care, they formed an image not drawn in light, but in memory. It showed a glow surrounding an absence, a luminous ring cradling a quiet center. This wasn't just a picture, it was a confirmation that Einstein's dreams were stitched into the fabric of reality, that the curved space we imagine truly bends the paths of photons. The Event Horizon Telescope didn't just capture data, it caught a feeling, the hush of extreme gravity, the soft echo of mass turned inward. It was a glimpse not just of an object, but of space-time shaped into a silent knot. The bright ring you've seen isn't the black hole, it's its echo. Light warped, delayed, and bent into a halo by gravity's hand. This halo is not a simple outline, it is a circle carved by the detour of light. Photons that pass near the event horizon bend around it, caught in orbits or flung into view by the black hole's extreme pull. The result is a ring, not of fire, but of patience. Some rays have traveled straight to us. Others have taken a curved path, looping partway around the black hole before escaping. The glow is uneven, shaped by speed and spin, brightness intensified where light races toward us. But at the center lies darkness, not because it is empty, but because light cannot return from within. This image is the silhouette of escape made impossible. Gravity sketches its own art here, and we are just beginning to learn to read it. Every pixel is a story of curvature, every flicker, a moment stretched by mass. And though the black hole itself remains hidden, its influence shines all around, a quiet outline made of delayed light. For the first time, we turned our gaze to the edge of forever. And there, in the quiet, we saw a circle, not of light, but of absence. That soft ring, captured by the Event Horizon Telescope, was more than an image. It was a moment, a breath held across decades of theory and patience. We had imagined black holes, drawn them, modeled them, even measured their pull. But to see one, to cradle its shadow in pixels and inference, was to feel the limits of perception dissolve. This was not a picture of a thing, but of what a thing does to space and time. It was like watching gravity draw a boundary between presence and disappearance. The circle was not a surface, it was a silence, a place where the story of light stops being told. Around it, photons danced and hesitated, some flung back outward, others held in orbit, and still more lost forever inside. We saw what we should not be able to see. We glimpsed an absence made visible by the struggle of light to escape, and in doing so, we glimpsed something deeper, that even in the darkest places, there are ways to witness, to wonder, to understand. The edge of a black hole became a mirror, and in it we saw ourselves, curious, quiet, and still reaching into the dark. When two black holes spiral into one another, they send out ripples in space. These waves stretch and compress the very fabric we drift through. These aren't waves in air or water, but in space-time itself, the silent scaffolding of reality. As the black holes draw close, their orbits quicken. They dance a final waltz, circling faster and faster, until at last, they merge with a tremble that races outward at light speed. That tremble is a gravitational wave, a whisper that reshapes distances ever so slightly, even here on Earth. It passes through us unnoticed, unless we are listening with exquisite precision. Instruments like LIGO and Virgo stretch beams of light across kilometers, waiting for a difference smaller than an atom. And when they feel it, we know, somewhere far away, two invisible giants became one. These mergers happen in darkness, but they sing across the cosmos. We cannot see the black holes collide, but we can feel the aftermath, the fabric of space itself, flexing like a breath. Each wave carries the echo of a union, the final sigh of gravity's deepest embrace. And so, even in silence, black holes find a way to speak. Gravitational waves are not sounds, but rhythms. They move through the cosmos like a bass note through silence. They do not echo. They do not shimmer. They pass through everything, subtly altering space itself. A stretch here, a compression there. If you could float perfectly still, you would never notice. But if you could measure 2 points in space with infinite precision, you'd feel the wave roll past like a hush through the stars. These ripples are born in moments of immense change, 2 black holes merging, neutron stars colliding, the universe itself expanding in its infancy. They do not need a medium. They are not carried by air or light. They are changes in the very gridwork of existence. Like a breath in a still room, they bend what was once unbending, leave a mark where none could be made before. They are not loud. They do not arrive with fanfare, and yet they speak of colossal forces, of ancient events unfolding far from here, far from now. Gravitational waves are not the voice of the universe. They are its heartbeat, slow, vast, and pulsing beneath everything we know. LIGO listens, not with ears, but with light. It measures distances so small, they vanish into the quantum hum, and yet it hears. In twin arms stretching 4 kilometers long, laser beams bounce between mirrors, waiting for the tiniest twitch in space itself. When a gravitational wave passes through, it warps one arm longer, the other shorter, not by inches, but by less than the width of a proton. And still, the light notices. The beam shifts, ever so slightly, and from that shift, a story unfolds, a story of black holes colliding, of cataclysms we'll never see, but can now perceive. LIGO doesn't just detect motion, it detects change in the structure of spacetime. Its silence is alive with listening, and when it hears a signal, the data is transformed into sound, a chirp, a rising tone, a final note in a cosmic duet. It's not a sound the black holes make. It's a sound we give to their gravity, a translation of their invisible dance into something we can feel, something we can wonder at. Through LIGO, we hear not with ears, but with awe, 2 black holes, dancing in silence, finally touch. Their merger sends out waves across the stars, a moment that echoes for billions of years. In that final orbit, their gravity becomes entangled. They swirl tighter, circling each other like shadows closing in. No light escapes their union. No flare marks the climax. And yet, something profound is released, not in brightness, but in motion. Space-time ripples outward, carrying the memory of the merger like a whisper etched into the cosmos. These waves stretch across galaxies, through voids, past stars and dust and time itself, until they brush softly against our instruments. Here on Earth, we feel what we cannot see. We record a ripple born in darkness, and from that ripple, we learn that 2 invisible things have become one. Their masses combine, their horizons merge, and a new black hole is born, silent, heavy, complete. This isn't an explosion, it's a folding, a closing of distance between 2 immense souls. And though the cosmos doesn't shout, it hums with the quiet aftermath of their embrace. We are left not with a bang, but with a signature, a cosmic sigh stretched across the fabric of everything. By the time the ripple reaches us, it's faint, gentle as breath, but it carries the story of a collision far away, long ago. It began in a corner of the universe we will never visit, between two black holes we will never see. Yet their final dance bent space-time in a way that never ends, a wave moving ever outward. That wave passed through galaxies and cosmic dust, through starlight and silence, across billions of years and inconceivable distances, and eventually, delicately, it reached Earth. Here, it shifted a mirror, altered a laser's path, nudged the smallest measurement ever made, and in that faintest touch, it revealed a truth. Something happened, something vast, something gravitational and grand. This echo is not just a trace, it's a message in motion, a memory without light. Even across time, even across silence, the universe finds a way to share what it has seen. And so, in the hush of a laboratory, beneath the hum of instruments tuned to the cosmos, we hear a collision that ended long before our planet was born. Some black holes are only a few times the mass of our sun. Others weigh billions, cosmic anchors around which entire galaxies turn. The smallest ones form from stars. The gravity condenses what once shone into something that no longer shines. These stellar mass black holes are common, scattered like dark seeds throughout galaxies. But then there are the giants. Supermassive black holes, millions or even billions of times heavier than our sun, sit quietly at the centers of galaxies. They don't chase stars. Stars orbit them, as if dancing around a sleeping god. These black holes are ancient. Their size defies intuition, stretching our understanding of what mass and gravity can do. How they formed remains a mystery. Did they grow slowly, over eons, or did they arrive already vast, born from the young chaos of the cosmos? The largest one we've found so far weighs more than 60 billion suns, and yet it is silent, still, a dark anchor holding its galaxy in place. The universe does not set a clear limit, so we continue to wonder, how big can a black hole truly be? And are there giants out there, still unseen, shaping the cosmos from the shadows? We've seen small black holes and enormous ones, but in between, things are quiet. These mid-sized mysteries may hide in faint corners of space, called intermediate mass black holes. They're neither the remnants of stars nor the monsters at galaxy centers. They are the missing link, the shadows that should exist but rarely show themselves. We suspect them when we find oddly moving stars in tight clusters, when gravity curves where it shouldn't, when X-rays flicker from places too small to host giants, yet too strong to be explained by chance. These black holes might weigh hundreds or thousands of solar masses, heavy but not colossal. If we find them, they might tell us how the biggest ones grew, whether supermassive black holes were once small, or if they skipped the middle entirely. But the universe is shy with its answers. These mid-sized enigmas stay tucked away in globular clusters, or perhaps in the halos of dwarf galaxies. Silent, elusive, watching. We're still listening, still waiting for a flicker, a tug, a whisper of motion that tells us something massive but modest is there, curled in the folds of space. In the cores of the brightest galaxies, black holes can grow to monstrous scales. Their mass is not a star, but a cluster of stars compressed into stillness. These are the ultra-massive black holes, heavier than entire star systems, quiet monarchs seated at the heart of luminous realms. They don't shine themselves, but their gravity pulls entire galaxies into shape. Surrounding them, Millions of stars orbit like fireflies around an unseen flame. These cosmic hearts weigh tens of billions of solar masses, yet they do not roar. They rest, they gather, and in their stillness, they shape the dance of everything nearby. The brightest galaxies, called quasars, often host these giants, their glow powered by the falling of matter into the abyss. And still, even that light is only the echo of approach. What lies within remains hidden. These black holes do not drift. They anchor. They do not burn. They bind. Like lighthouses turned inward, their mass shapes space into silence. And though they do not move, the universe flows around them, like rivers meeting a mountain too deep to see. TON 618 is one of the largest black holes we know. Its mass is staggering, billions of suns inside a single silence. Discovered in the light of a distant quasar, TON 618 is more than a number. It is a monument, a reminder of how vast the cosmos can be. Its light took over 10 billion years to reach us, meaning this black hole was already colossal when the universe was young. We see it not as it is, but as it was, long before Earth had formed, before the sun had burned its first hydrogen. TON 618 weighs over 60 billion solar masses. Imagine all the stars in a galaxy, all their light and fire. Now imagine them gone, replaced by a single dark presence. That's TON 618. And yet, despite its scale, it whispers. It doesn't thunder. Its voice is gravitational, bending space without sound. We can only observe its surroundings. The glow of falling matter, the flicker of distant X-rays. And from those patterns, we guess at the giant within. This is the poetry of astronomy, finding enormity in absence. TON 618 doesn't shine, but it teaches us what scale can mean, and what stillness too can hold. Could black holes grow endlessly, or is there a point where even gravity cannot deepen further? We don't yet know. In theory, a black hole can continue to grow as long as it feeds, collecting stars, gas, even other black holes into its embrace, like a quiet well that deepens with every falling drop. But physics may draw a boundary somewhere. Perhaps there's a point where space-time can no longer fold inward, where the laws that define gravity begin to unravel. Or maybe the limit is set not by nature, but by chance, by how often matter gathers and how much time it has. The largest black holes we've found seem impossibly vast, but the universe is older than our measurements, and its corners remain dim and unexplored. There may be black holes we haven't seen, larger than TON 618, resting at the edge of known light. Still, with each new discovery, we're reminded the universe is not constrained by our expectations. Gravity may go deeper than we can follow. The limit, if it exists, might not be a wall, but a whisper waiting in the silence between stars. Some theories suggest our entire universe might be the inside of a black hole, a space folded into itself with no way out and no need for one. It's a strange idea, but one that stirs something quiet inside. Imagine the Big Bang not as an explosion into emptiness, but as the birth of space inside a vast, unseen horizon. From the outside, it would seem like a black hole, light unable to escape, space curving inward, but from within, it would feel endless, expanding, full of galaxies, stars, time, and thought. This model suggests that black holes might not be ends at all, but beginnings, sealed pockets where new universes grow. We can't test it directly. We can't step outside our own cosmos to peer in, but the math fits in curious ways, hinting that what we call inside and outside may be illusions, boundaries that feel real, but blur in the deep language of gravity and quantum fields. If true, it would mean we are already inside something vast, held gently in a fold of space, not trapped, but cradled, not falling, but expanding forever, within a silence we cannot leave and do not need to. In this model, the Big Bang isn't the beginning, it's an emergence. From inside a singularity, a new space unfolds. This idea turns our understanding of beginnings inside out. It suggests that what we see as the origin, the Big Bang, is not the first step, but a gentle unfolding from another realm. A black hole in one universe might curve space so tightly that it births another universe within. Inside that fold, time begins anew. Dimensions bloom, particles emerge, stretch, and begin to form the scaffolding of stars. Our own cosmos could be the interior of such a transformation, a child universe growing from the silent collapse of another. In this vision, every black hole is not just an end, but a seed, a potential for space-time to regenerate, hidden behind a veil of gravity. We cannot travel through such a singularity, not with ships or instruments, but our equations point toward possibility, a kind of cosmic rebirth echoing through layers of space-time. If this is true, it means the universe is not a single story, but a branching tree of realities, one giving rise to the next in quiet succession. And in that tree, our own story is still unfolding, deep inside a dream that began with a collapse. Every black hole might birth a new universe, one step inward, infinite steps beyond. The event horizon could be more than a boundary. It could be a womb. Inside, space doesn't end. It transforms, collapsing not into a void, but into a tunnel of expansion. The singularity at the center becomes the spark, igniting time, dimensions, and energy in a pocket we cannot see. From our side, it looks like silence, but inside, it might be blooming, galaxies spiraling outward, stars beginning to burn, particles cooling into structure. These child universes would be unreachable to us, sealed off by the very nature of space-time, and yet they would carry the imprint of the parent universe, echoes of the physics, the patterns, perhaps even the information that came before. In this view, reality doesn't move in a straight line. It buds, regenerates, curls inward, and then blossoms outward again. The cosmos becomes a garden of horizons, each one containing its own unfolding world, cradled in shadow. We may never see these other universes, but their possibility makes our own feel more wondrous, not alone, but one note in an eternal song, a single breath in a universe that inhales through collapse and exhales new creation. Black holes are the most entropic objects we know. Their surface encodes vast information. The bigger they are, the more they remember. Unlike everyday objects, where disorder hides inside, a black hole's entropy lives on its skin, its event horizon. That soft outer boundary holds the imprint of everything that has ever fallen in, not as pictures or memories, but as patterns of quantum information woven into the surface like ripples in silk. This entropy, this measure of disorder, is vast, and the larger the black hole, the more of the universe it quietly carries in its surface code. It's as if size itself remembers. In the darkness, where no light escapes, the black hole becomes not just an object, but a ledger, a keeper of cosmic secrets written not in ink, but in geometry. The quiet mathematics that describe entropy here feel more like poetry, formulas where gravity, temperature, and surface area become metaphors for memory. No matter what falls in, starlight, dust, atoms, The hole's surface adjusts, expanding slightly, making room for the story. It doesn't forget. It reshapes itself with calm precision, reflecting a truth we're only beginning to understand, that the edges of things, not their insides, may hold the deepest meaning, that silence itself can remember. Equations whisper that horizons hold not just mass, but meaning. That information, not matter, defines the edges of space. At the threshold of a black hole, something elegant unfolds. It's not just the boundary between light and dark, but a veil of profound structure. Quantum theory and general relativity, once thought separate, begin to speak the same language here. In murmurs of surface area, curvature, and hidden code, the boundary becomes more than a location. It becomes a canvas, one that holds the entire internal story of the black hole, projected outward in soft geometry. Every bit of mass that vanishes within seems to leave a trace, not inside, but at the edge, like the outline of a vanished thought. These equations suggest that reality is not simply what's inside a space, but what defines its boundary, that perhaps the universe itself is a kind of boundary-defined space, its edges holding the clues to everything within. And so, when we look at a black hole, what we see is more than just a gravitational well. We're seeing the outermost page of a cosmic diary, written in the quiet script of entropy and light. The event horizon isn't silence, it's structure. It speaks not with sound, but with symmetry. And if we listen closely, through mathematics and light, we can almost hear it telling the story of everything it contains. It seems strange, but black holes may bring more order than chaos. They organize gravity, capture entropy, and turn collapse into calm. In the hush of deep space, black holes act like organizers of the cosmos. Where once there was motion, turbulence, and fragmentation, black holes gather it inward, not violently, but decisively. They tame the wildness of stellar death, forming a single, unified presence, a stillness with gravity so complete, even light yields to it. Entropy may rise, but it becomes contained, structured along the surface, elegantly proportional to the horizon's area. It's as if the black hole doesn't destroy complexity, it curates it, wrapping chaos into order, hiding vastness behind a simple curve. In a universe where everything trends toward disorder, a black hole stands as a paradox. It welcomes entropy, but also imposes boundaries. It simplifies, it tidies up the end of stars, the fall of gas, the collapse of time. In its silence, it is not reckless, but refined. A slow conclusion rather than an explosion. Collapse becomes calm. Gravity becomes rhythm. And in that quiet transformation, something beautiful emerges, a kind of cosmic punctuation mark, drawing the sentence of a star's life into a single elegant dot. Not the end, just a stillness. At the edge of a black hole, heat and gravity speak the same language. Temperature, entropy, curvature, all woven into the same equation. There, on the edge of forever, two great forces of nature meet and merge. Thermodynamics, with its rules of energy and heat, whispers to gravity in the shared dialect of surface area and curvature. At a black hole's event horizon, we find that temperature isn't just a measurement, it's geometry. Entropy isn't just disorder, it's shape. Each black hole has a temperature tied not to its inner fire, but to its mass and surface. Hawking showed us this, that black holes, far from being cold and dead, radiate faint warmth, a thermal glow born from quantum fluctuations at the edge. The laws of black hole mechanics align almost perfectly. with the laws of thermodynamics. The surface area plays the role of entropy. The gravity at the horizon mimics pressure. The mass becomes internal energy, and suddenly, the physics of heat becomes the poetry of space. In this strange harmony, the boundary of a black hole becomes a laboratory, not for destruction, but for understanding. Gravity, it seems, is not just pull. It's temperature, time, and thermodynamic grace. It curves, it stores, and in its quiet presence, it teaches us how deeply everything is connected. A black hole's surface area tells us how much it knows. The bigger the horizon, the more hidden stories it holds. Unlike anything else in the cosmos, a black hole doesn't keep its secrets inside. It wears them across its surface. The event horizon becomes a ledger of entropy, storing the echo of everything that ever crossed it. Each bit of information, every particle, every photon, not gone, but softly encrypted in the stretch of space around the edge. It's a quiet revelation that the more a black hole consumes, the more its surface grows, and the more stories it cradles just beneath visibility. This is not entropy as disorder, but entropy as memory, a measure not of chaos, but of content. The smooth black curve of a horizon becomes a kind of cosmic script, written not in words, but in surface area, and it whispers that even in the deepest silence, something is being kept, not destroyed, not forgotten, just folded away behind a boundary where time and distance blur. The greater the area, the greater the capacity for memory, not memory as we know it, not vivid or accessible, but a gentle hum of presence, a soft archive of the universe's quietest falls. Jacob Bekenstein first imagined that black holes could have entropy, that even darkness could be counted, measured, and softly understood. It was a radical idea at the time, that something as silent and final as a black hole might still obey the quiet laws of thermodynamics, that even in the dark, numbers could still apply. Bekenstein imagined that a black hole, though invisible inside, was not beyond reason. Its surface, its event horizon, could be the key. He proposed that its area reflected entropy, that black holes were not ends of physics, but new chapters, places where information wasn't erased, but transformed, wrapped into geometry, folded into gravity. This soft insight opened the door to a deeper understanding of black holes as thermodynamic beings, not inert, but in slow dialogue with the universe around them. His equations hinted at bridges between worlds, gravity and heat, entropy and surface, silence and information. It was not just a mathematical proposal, it was a poetic one, that even in the deepest dark, something could still be counted. That knowledge isn't limited to the visible. And in that gentle equation, Bekenstein gave us a gift, a way to listen to the silence, a way to believe that every fall into shadow leaves a trace. Entropy flows forward, and so does time. Black holes grow, but do not shrink, like clocks ticking only in one direction. A black hole doesn't unwind, it doesn't dissolve, it gathers, it grows, and in that slow gathering, it obeys the arrow of time. The one-way river of entropy, always moving forward, each particle that falls in, each flicker of starlight that vanishes beyond the veil, deepens its mass and stretches its horizon. The black hole remembers not the details, but the weight, the inevitability of accumulation. This is time in its quietest form, not measured in seconds or orbits, but in deepening gravity, in increasing stillness. The horizon doesn't pulse, it expands, like a shadow that only lengthens, never retracts. In this way, a black hole is a cosmic clock with no hands, just direction, no tick but drift, no chime but consequence. The universe around it changes, cools, and decays, but the black hole holds steady, its growth a whisper of the past, stretched into the future. And so we see the truth mirrored in shadow, that time, once begun, does not return, that even in collapse there is a forward path, always forward. Some models suggest time might flip inside the horizon, that what falls forward here could move backward there. It's a soft, strange idea that time, so familiar in its flow, could bend or reverse once past the veil. From the outside, everything falls inward, but from within, could something else emerge? Could time itself unfurl backward, not in rewind, but in redefinition? Inside the horizon, space and time swap roles. Direction loses meaning. The coordinates we know drift into abstraction. And in this quiet rearrangement, some theorists see the possibility that what we call after might become before, that an interior observer, if such a thing could exist, might not fall into the singularity, but away from it. Time then would not be a river, but a loop, not a path, but a fold. Of course, we cannot know. The equations flicker at the edge of certainty, and the answers remain just beyond reach. But the dream persists, that the rules may not end at the horizon, only shift, that deep inside, the universe might remember another way of turning, another direction, another time. The laws of physics remain unchanged in many directions, but inside a black hole, symmetry breaks softly, not with noise, but with inevitability. Outside, the universe is balanced, push and pull, motion and stillness, time forward and space around. But step across the event horizon, and the harmony bends. The graceful mirror of space-time becomes something else. In that fall, once you cross the invisible line, there's no turning back, not because a force stops you, but because the shape of space itself no longer allows return. Direction still exists, but it is singular, inward. Time itself no longer leads you onward, it draws you in. Symmetry becomes a memory. The equations still work, but they whisper a new kind of truth. Inside, everything that once could go both ways now moves only one, and the silence of that fall is not chaos, but a quiet inevitability. Even symmetry, the great rule of nature, bows here, not broken with violence, but softened into surrender. Some scientists believe black holes carry soft hair, faint imprints left by what fell in, not visible, but not gone. It's a poetic name for something deeply mysterious. The idea that black holes aren't smooth and forgetful, but subtly marked by what they've consumed. These traces, known as soft hair, aren't strands or shapes, but gentle asymmetries, delicate ripples in the field, like fingerprints in the dark. They don't shine, they don't shout, but they may preserve the quiet essence of all that entered, a photon's angle, a particle's spin, a whisper of information lingering at the edge. If true, it means black holes are not tombs, but libraries, unreadable, perhaps, but not erased. The soft hair does not contradict the silence of the singularity, but enriches it, like grains of memory scattered across a sleeping mind. These gentle variations suggest that even the deepest void is not truly empty. It remembers not everything and not clearly, but something, enough. These hairs may be clues, gentle threads of information left on the surface, not enough to see, but enough to hint that memory lingers. They flutter like shadows over silence, not strands of matter, but echoes in the field. When something falls into a black hole, we once thought it was lost, erased from existence. But these so-called quantum hairs offer a softer ending. They are not full messages, not stories written clear, but traces, quiet distortions in the horizon's quantum texture. As if the black hole is not bald, but faintly brushed by everything it has ever touched. These subtle variations might hold the spin of a particle, the angle of a photon, the tiniest signature of what was. Not enough to rebuild the past, but enough to believe it still matters. These hairs suggest that the black hole does not forget completely. It carries a ghostly memory, stitched into its skin, wrapped in the gentle curvature of its edge. Like dreams etched in starlight, they whisper of a deeper logic, one where nothing is truly gone. In physics, information must be preserved, even in silence, even in darkness. Nothing is truly lost. This is not belief, but law, the conservation of information written into the very foundation of quantum mechanics. It says that no event, no particle, no flicker of existence can vanish without trace. So when something falls into a black hole, physics holds its breath. Where did the information go? If black holes are erasers, the universe's equations unravel. But if the horizon holds the secret, if memory lingers in soft hairs, in gentle radiation, in quantum shimmer, then silence is not emptiness, but encryption. Information may be tangled, hidden, and unreadable, but it is still there, even when the black hole evaporates, releasing its last sigh of Hawking radiation. The story may not end in loss. It may end in transformation, from presence to pattern, from voice to vibration. The universe keeps its record even in the dark. A star may vanish, a signal may fade, but the energy, the structure, the history, it may simply change shape. Death, in the language of physics, is not an ending. It is a transformation. When a star crosses the event horizon, its light no longer reaches us. Its surface, its sound, its shape, they disappear from view. But the black hole remembers. It folds the star's mass into itself, curves space more deeply, and carries the imprint of everything that once was. Inside, the structure may collapse beyond recognition, compressed into forms we cannot see or measure, but the energy persists. The equations tell us. Mass becomes gravity, gravity shapes time, and time never forgets. What dies is the visible, not the real. The song stops playing, but the vibration still moves through the cosmic fabric somewhere. What falls into a black hole may lose its name, its boundaries, its voice, but not its being. The event horizon holds the ghost of what was, a quiet imprint, softly clinging to the border between knowing and not. This boundary, delicate, invisible, final, is not a wall, but a veil. It is where time bends so deeply that forward becomes forever. And yet, at this threshold, something remains. The object may have fallen inward, but its influence lingers here, in the way light bends around the edge, in the temperature of the radiation that seeps outward, in the gravitational hush that pulls on the space nearby. It is not memory in the human sense, but resonance, a trace, a pressure, like a footprint in soft sand just before the tide. What survives on the edge is not the thing itself, but its shape, held briefly in spacetime's breath, neither fully gone nor fully present, a whisper at the border of forgetting. No telescope can see what's beyond the veil, but our minds drift there easily, dreaming of what lies behind the fall. And so, you drift too, gently, with no need for answers. In the soft hush of midnight thought, black holes become dream wells, not frightening, but curious, not endings, but doorways the universe forgot how to open. You imagine falling, not with fear, but with wonder, as if sleep itself were a descent through space, each breath taking you deeper into the unknown. Beyond the horizon, beyond the surface of physics, lies only silence. And yet, in that silence, your thoughts find room to grow, to imagine, to dance. The stars do not resist this falling. They do not panic at what they cannot see. They move with grace always. So too does your dreaming mind. Perhaps you float past the veil, through the curvature of memory, into the soft mathematics of what might be. And if beyond the edge there is anything, maybe it feels like this, like floating weightless, wrapped in shadow, surrounded by gentle gravity, a place where time forgets how to count and you forget how to worry. Just this hush, just this falling, just this dream. Some suggest information seeps back out over time, not in beams, but in delicate particles, each one carrying a trace. These particles don't shout, they don't blaze through the dark, they drift, slow and shy, like stories told in reverse, each one a soft murmur, a shimmer at the edge of emptiness. It's as if the universe, over eons, is exhaling its memories, not all at once, but like breath returning after stillness. Hawking radiation, they call it, not just light, but legacy. The remnants of what fell inside, transformed and scattered, whispering their way back into space. Maybe nothing is ever truly lost. Maybe everything simply changes form, from mass to message, from shape to signal. And so the black hole fades, not in silence, but in soft communication. Its surface trembles with quantum echo, a language written in disappearance. The darkness does not forget. It simply waits, slowly unraveling its secrets, like pages turning on a windless night. You listen now, with your breath slow and your thoughts quiet. And in that stillness, you imagine a single particle escaping, soft as ash, carrying the shape of something that once was a star, a sigh, a story. Nothing loud, nothing urgent, just the slow return of something once surrendered, like light unspooling across time. Maybe black holes are not destroyers, but archivists, keeping what they take in coated on their skin. And if so, then nothing is truly gone. Each fallen star, each whisper of matter or burst of light may be written faintly across the surface like a cosmic braille, not visible, not legible, but real. In this idea, the event horizon becomes a quiet record, a silent scribe of everything that crossed its edge, like wind-blown patterns on sand dunes, subtle but enduring. These marks of memory would persist even as the object itself vanishes from view. The black hole becomes a historian of sorts, not with books or ink, but with curvature and quantum tremble. Its very shape tells a story of what once drifted near, of what now rests inside. And though we cannot read these records with our instruments, perhaps they are still there, gently pulsing in the gravity, waiting for a future physics to whisper them back into form. Think of a black hole as a library with locked doors. The books inside are sealed, but the titles still shine faintly on the shelves. Each title is a trace, a soft echo of what was, flickering like gold leaf in the dark. They don't tell you the whole story, but they hint. A particle's momentum, a wave's frequency, the subtle folds in a falling field, all stored, perhaps, along the black hole's border. This is the idea of holography made tender, not a machine's archive, but something quieter, gentler, a memory not of facts, but of presence. Even as entropy rises and time flows forward, the horizon holds this hush. These archives are not for us to open, not yet, but the possibility lingers that the universe forgets nothing, even in its darkest corners, that every collapse leaves a trace, that even what falls beyond reach is still part of the story, just written in a different tongue along the edge of space-time itself. When a star falls in, it gives off one last shimmer, a final flare before silence, as if saying goodbye to the universe. This farewell glow is not loud or frantic, but soft, a brief radiance stretched across time. As the star's outer layers spiral inward, they heat and shine, casting one final light into the darkness. For a moment, the star becomes brighter than ever, its story flaring at the edge of forever. To a distant eye, this shimmer may last and last, frozen on the boundary, never quite fading, a light that lingers longer than its source. The black hole does not rush this process. It waits, still and silent, as gravity smooths every trace of the star into spirals of memory. Even as the core disappears, light continues to curl and bend along curved paths, warped by space and stretched by time. The last image of the star becomes a kind of echo, painted onto space-time like a fading photograph, and when it is gone, truly gone, what remains is not absence, but a story completed, a sentence with no punctuation, just breath drifting slowly into the next. Each black hole holds a history of stars, gas, time. Their gravity is not just force, but story. They are the silent scribes of the cosmos, recording collapse and creation, not in words, but in curvature. Each swirl of matter, each captured photon, becomes part of a layered tale etched into the fabric of space. Around them, stars dance and disappear, light bends, vanishes, and sometimes reemerges as a flare, a ripple, or a whisper in radiation. Though they speak no language, black holes tell of ancient collisions, of galaxies that met and merged, of gas that once burned in stellar cores and now spirals in quiet descent. Their memories are not stored like ours, but encoded in the way they bend space, the way they spin, the way they shine faintly at the edge. Scientists who study black holes listen for these stories in the faintest X-rays, in the trembling of gravitational waves, in the patterns of orbiting stars. What we call data, they call remembrance. And the more we learn, the more it seems that black holes are not ends at all, but quiet narrators, keeping the universe's history in a language only gravity can speak, a language that waits patiently, whispering softly across time. In a cosmos full of motion, black holes are still points, places where movement ends, but meaning begins. They do not rush or spin with chaos, but wait, heavy and unmoving, like commas in the sentence of space. In their presence, time itself bends, slows, and quiets. While stars blaze and galaxies swirl, black holes remain poised, silent, unmoved. Their stillness is not absence, but presence, dense, watchful, patient. Around them, everything reacts. Light dances, gas spirals, stars fall into elegant orbits. But at the core, there is calm, deep, dense calm, as if all of space inhales and holds its breath. This stillness becomes a kind of rhythm, not with beats or pulses, but with pauses. Black holes hold the memory of everything that has touched them, and they do so without motion, without sound. Their silence is full, their quiet is deep, and maybe, in a universe that's always rushing, that stillness is something sacred, a reminder that sometimes the most powerful thing is to simply be, to rest, to hold. And now you're drifting too, gently, slowly, across this quiet sky, through theories and thresholds, through silence and sleep. You've walked the edge of singularities and traced the spirals of galaxies. You've listened to whispers of light, of entropy, of dreams held on the edge of space. And now, in this final chapter, there is nothing more to do. Just float in the hush of cosmic memory, in the gentle gravity of rest. Let your breath deepen, your thoughts soften. Let your weight sink as if into the warm pool of starlit water. There's no rush to wake, no need to understand. You are part of this story now. A quiet mind in a quiet night, wrapped in the glow of a universe that never hurries. Maybe you're already asleep. Maybe you're right on the edge. Either way, you're safe. You're held. Thank you for traveling so far. Now let yourself drift, not to solve, not to reach, but to simply be in the beautiful stillness of the dark.